Hello, myself Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding coupling and cohesion, which can be used in the software design. The topic learning outcome is mapped with the course learning outcome of CO4, which is understand the importance and need of design and explain the various approaches of designs. In this video, the basic agenda is what is software design, what are the design process and concepts, how modularity, functional independence can be achieved with the coupling and cohesion, and what are various categories of coupling and cohesion. What is software design? A design is a mechanism to transform user requirements into some suitable form which helps the programmer in software coding and implementation. So, the phased approach of software development generally comprises of analysis phase, design phase, coding phase and testing phase. During analysis phase, the requirement from the customer is gathered and can be analyzed with requirement engineering process. There, identification or discovery of requirements, prioritizing the requirement, classifying the requirement, validating the requirement with different approaches. All the validated requirements are documented in the SRS. So, the design must be used to convert these documented requirements that are gathered in the analysis phase can be converted into suitable form so that the software engineer can easily code it for implementation. So, it deals with representing the client requirement as described in the software requirement specification document into a form that can easily implementable using programming language. So, in software design, the system is considered to be a set of components or modules with clearly defined behavior and boundaries. So, the project can be divided into small manageable units. Those can be generally referred as components and modules. So, the structure of these components can be represented with the software design. There are two levels of software design. One is the external design level. Second one is internal design level. External design level is majorly focused on how the project can be stimulated with the external environment. So, the user interactions with the project is basically concentrated in the external design. So, focus on the modules that need their specifications so that the interactions are how easily the user must interact with the project through interfaces is majorly evaluated with the external design. The second one is internal design. In this, the basic requirements that are gathered are planned how they can be in the implementable form to form the structure of the project to be developed. Three phases of software design. One is interface design, second one architectural design, third one detailed design. Interface design majorly focus on the how interaction over boundaries of the project can be carried out. Architectural design focus on how the components or structure of the design are formed and how they are related to provide the intended functionality. Detailed design is greatly involved in the implementation aspects of the project. The first phase of design is the interface design. Interface design is the specification of interaction between a system and its environment. So this phase proceeds at a high level of abstraction which respect to the inner working of the system. So it provides how these interactions are provided in an abstract way. Only the needed information is provided. It can hide how to implement them. The design problem statement produced during the problem analysis step should identify the people, other systems, and devices which are collectively called the agents that can be used in the interaction through interfaces of the application. The second phase is architectural design. Architectural design is the specification of major components of a system, their responsibilities, properties, interfaces, and the relationship and interactions between them are considered during architectural design. In architectural design, the overall structure of the system is chosen, but the internal details of major components are ignored. The third phase is detailed design. Design is the specification of internal elements of all major system components, their properties, relationships, processing, and their algorithms and the data structures. So, in the first phase of the interface, the abstract way of interaction must be modeled without specifying the inner details how to implement them. But in the detailed design, the implementation details are concentrated. So the data structures, algorithms, and computational processing, how they are to be provided, is considered in the detailed design. In detailed design, each module is explained carefully, design, the data structure, and algorithms. So the stage outcome is the document in the form of a module specification document, in which each module, what the entry condition, exit condition, what are the input output of each module, and what computational processing must be provided by the module is considered during the detailed design. So the general design concepts are included: the abstraction, information hiding, refactoring, modularity, pattern refinement, architecture, and the refinement. The abstraction provides a solution so that it's stated in large terms using the language of the problem environment at the highest level of abstraction. But at the lowest level of abstraction provides more detailed description of the solution. So, a sequence of instructions that contains the specific and limited functions refers in the procedural abstraction. A collection of data that describes a data object is a data abstraction. So, in the two types of abstraction that we discuss, that is data abstraction as well as procedural abstraction. In case of data abstraction, the data on which a class must be operate is concentrated. For example, look into the door class, in that on which data it has to be operated is mentioned in the data abstraction. But in case of procedural abstraction, for this door class, what are the specific methods or operations to be performed? One functionality is the open, how it can be implemented with the algorithm is concentrated on the procedural abstraction. The next design concept is the architecture. The complete structure of the software is known as software architecture. Architecture provides the basic components or the modules of the system, how they are interacting with each other in a specialized way. The aim of software design is to obtain an architectural framework for the project. The design pattern is the another design concept which describes a design structure that solves a particular design problem in a specified content. So each design pattern is to provide a description that enables a designer to determine whether the pattern is applicable to the current work. It solves the specific problem or not. Whether the pattern can be reused. Reusability is the basic concern in the design patterns. Whether pattern can serve as a guide for developing a similar but functionality structurally different pattern. The next design concept is information hiding. Modules must be specified, designed so that information like algorithm, data presented in the module is not accessible for other modules not requiring that information. Only the required information is passed among the modules. So data accessing can be restricted generally with the help of access specifiers. So hiding implies that effective modularity can be achieved by defining a set of independent modules that communicate with one another only that information necessary to achieve the software function. The next design concept is the modularity. A software is separately divided into name and addressable components. So based on the principle of separation of concern, the project can be divided into small manageable units. Those can be generally referred as components or modules. So they can be integrated to satisfy the problem requirements. Modularity is the single attribute of the software that permits a program to manage easily. So functional independence is the another concept of the design which is based on the separation of concern and related to the concept of modularity, abstraction and information hiding. So independent modules are easier to maintain because the secondary effects caused by the design or code modification are limited. Error propagation is reduced. So the functional independence can be greatly limited in order to avoid the error propagation when one dependent module is changed. So the functional independence is accessed using two criteria. One is coupling and cohesion. So the project can be divided into small modules. So these are the module 1 which consists of variety of functions, a collection of functions which will provide computational capacity for that module. Here one more module which is having a set of functions to provide the intended functionality. So here coupling is how these two modules are related. So the degree of relationship in order to provide the functionality of one module with other modules is defined with the coupling. But the cohesion is the single-mindedness of this module in order to providing the intended functionality. So these two are greatly used in the functional dependencies. So cohesion is a measure of the degree to which the elements of the module are functionally related. So a cohesive module performs a single task and it requires a small interaction with other components in the other part of the program. So basically, cohesion is the internal glue that keeps the modules together. A good design technique must be high cohesion, must be incorporated in the design. Variety of cohesion approaches are possible. One is coincidental cohesion, second one logical cohesion, temporal cohesion, procedural cohesion, communicational cohesion, sequential cohesion, functional cohesion. In the coincidental cohesion is when part of a module are grouped arbitrarily, the only relationship between the parts is that they have been grouped together. So, elements contribute to activities with no meaningful relation to one and another. So, similar to logical cohesion, except the activities may not even be the same type. So, difficult to understand and maintain with strong possibilities of causing side effects every time the module is modified. In the logical cohesion, where the parts of the module are grouped because they are logically categorized. A relationship between the functionalities can be achieved with logical cohesion. So, even if they are different by nature, they are grouped under syntactically logically related to provide the intended functionality. For example, grouping of all mouse and keyboard input handling routines are the best example of logical cohesion. Next variety is temporal cohesion. Temporal cohesion is when parts of a module are grouped by when they are processed. So, to provide the intended computational capacity, these modules are grouped. The parts are processed at a particular time in the program execution. Next is procedural cohesion. Procedural cohesion is when part of a module are grouped because they always follow a certain sequence of execution and commonly found at the top of the hierarchy such as main program. So the generally control modules can be used for the procedural cohesion in order to handle the lower level modules in a tree structure of hierarchy. This cohesion is similar to sequential cohesion except that elements are unrelated. So a module is said to process procedural cohesion if the set of functions of the modules are part of the procedure algorithm in which certain sequence of steps have to be carried out for achieving an objective. Communicational cohesion. A module is said to have communication cohesion if all functions of the module refer to or update the same data structure. Elements contribute to activities that use the same input-output data. Not flexible. For example, if need to focus on some activities and not the others, possibly links that cause activities to affect each other. So better to split the functional cohesion once so that the errors propagation can be prevented. Next one is sequential cohesion. Sequential cohesion is when part of a modules are grouped because the output from one part is the input to other part like an assembly line. Example, a function which reads data from a file and process the data. So usually have good coupling and is easily maintained. Not so readily reusable because activities that will not in general be useful together. Next variety of cohesion is functional cohesion. Functional cohesion is when part of a module are grouped because they all contribute to a single well-defined task to the module. Example, lexical analysis of an XML string. And this cohesion is focused, strong, single-minded purpose and no elements doing unrelated activities. The other term that can be discussed in the functional independence is the coupling. So coupling is an indication of interconnection between the modules in the structure of the software. So in the software design, coupling plays a major role, and a good design technique of coupling is low coupling must be maintained in the software design. Variety of coupling are available. One is data coupling, second one stamp coupling, third one control coupling, fourth one common coupling, fifth one content coupling. The data coupling occurs between two modules when data are to be passed by parameters using a simple argument list, and every item in the list is used. So each and every item must be used in the computational processing in the data coupling. So consider an example. One, customer retrieving of customer information, and which can use retrieve of customer address only. Data is passed by through arguments to the function, but only few items must be used in the data coupling. Another variety of coupling is stamp coupling. Stamp coupling occurs between modules when data are passed by the parameters using a data structure containing the fields which may or may not be used. So, the data of the customer information retrieval and the retrieval of customer address, this data must be retrieved by using the stamp coupling. Customer details data structure is passed, in that only customer address can be used. All the data may or may not be used in case of stamp coupling. But in case of the data coupling, the entire data must be used. Next is control coupling. In the control coupling occurs between the modules when data are passed that influence the internal logic of a module. For example, flags and switches. So here, retrieval of customer information, retrieving customer name and address, but this information is passed or not, a flag must be indicating. So this control information is effectively indicated with the help of control coupling. These flags can be used and can affect the computational processing defined in that function. Next variety is the common coupling. Common coupling occurs when the modules communicate using global data areas. For example, universal common data areas. In the C language, allows the developer to declare a data elements as external, enable it to be accessed by all modules. So in C language, there is a storage class specifier which is used to represent a external data. Keyword is available in the C. By using this keyword, if you declare the variables, those can be accessed by all modules of the program. So, common coupling is also known as global coupling. Next one is content coupling. Content coupling occurs between two modules if one refers to the internals of other module. For example, if module branches to another module. So, branching logic implemented and which is in turn reflected to other module. If one module refers to change data in other module, or one module alters a statement in another module. So, in practice, only assembler language allows content coupling. Refinement is another design concept which can be used in the software architecture, which is used to in the top-down design approach specifically to process the elaboration. A program is established for refining levels of procedural details. A hierarchy is established by decomposing a statement of function in a stepwise manner till the programming language statements are reached. Refactoring is also greatly affecting the software design, which is recognition technique which simplifies the design of components without changing its functional behavior. Refactoring is the process of changing the software system in a way that it does not change the external behavior of the code, still improves its internal structure. Design classes are one more design concept. This model, the software is defined as set of design classes. Every class describes the elements of problem domain and that focus on features of the problems which are user visible. So in this video, I discussed about what is software design and what are various design concepts used in the software architecture, and majorly concentrating on the two terms coupling and cohesion with various types of coupling and cohesion, and the references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.